Hello, everybody. Welcome back to another lesson. Again, we're going to start off with a cool joke. Why do math teachers such as myself wear glasses? It's so that we can improve division. Improving division, vision, eyesight, vision, division, times tables, division. Okay. Speaking of division, we will do some division today, but I wanted to show you something because I think I'm pretty cool. I took this nice photo of when I went to, and I think I do this every time. I share the whole desktop, but really I just need you to see this. Okay, so I took this nice photo and it is what I would say exactly how I saw it when I took it. Right now, but what we can do here is we can change the ratio and we can mangle it a little bit and make it look funny. Right, it'll either look short and stout, squished, or it'll look like tall and skinny. And I'm sure you guys have at some point messed around with photos like this and made everyone look really funny, especially if their faces. Right, but what we want to do is when we're dealing with ratios, we actually want to deal with them in the same ratio. So we want to preserve the ratio so everything still looks the same, whether it's big or small. Right, hopefully that makes a bit of sense. Now I'm going to show you that that's what we're going to do today. So join with me, write down this heading. We are solving ratio problems and we're using ratios to find the quantity of an unknown amount, and the goal is to preserve the ratio. Okay, we don't want to mess things up. If you're cooking a recipe and you mess up the ratios, you're going to be eating something very, very different, probably not very nice. Okay, let's take a look at a question. Now, the ratio of tin to lead in a particular type of solder is 8 to 5. So tin and lead are just different types of metals, and solder is normally the metal that you melt to mix other or to stick other metals together. So I just want to write here that tin to lead, right? It's going to be very helpful for us if we write it down. Tin to lead, and they've told us is 8 to 5. Now, that's the information that they've given us, and it's in that order. There's 8 parts tin, 5 parts lead. So for the first one, hopefully it's fairly easy. I'm just going to take a look here and be like, okay, well, I know that my ratio is 8 to 5, but it says here, it says how much tin is needed to be mixed with 35 kilograms of lead. Right, so what I'm going to do is I'm going to rewrite the ratio, but now I know that there's 35 kilograms of lead, and so lead is the second number. Right, so I'm going to write it at 35, and now I need to find what this number is here. Now the way that I do that is I need to see how did I get from 5 to 35? Well, this one's a little bit easy for me to see. I just need to multiply by 7. So guess what? Multiply by 7 on both sides. 8 times 7 is 56. So here, if I've got 35 kilograms of lead, the way I answer this question is we need 56 kilograms of tin. There you go. Now let's take a look at this one here. Let's take a look at part B. Slightly different, a little bit trickier. So part B, it says how much lead is needed to be mixed with 70 grams of tin. Now again, my ratio is 8 to 5, but now what happens is I want to get from 8, and this time I'm going to have 70 grams of tin, or 70 grams. So now I need to find out, okay, how in the world do I get from 8 to 70? And then from there, I can figure out how to get from 5 to this unknown number, preserving the ratio. So this one's a little bit harder because 8 doesn't go into 70 nicely. So what I would do is I would put in my calculator, I would go 70 divided by 8. Right, so, and then the number that I get here is that's what I need to divide it by. So if I put 70 divided by 8 in my calculator, I get divided by 8.75. Hopefully you can see that's a little bit small. Let me fix it. Divided by 8.75. Okay, so that's how I get there. Now, how would I go the opposite way? If I wanted to go not from 70 to 8, but from 5 to the other number, what's the opposite of dividing something by 8.75? Well, you guessed it. It's times 8.75. Okay, so let's go 5 times 8.75, and you put that in your calculator, and you'll get, I can't fit it in the box, so I'm going to write it here, 43.75. All right, so to answer this question here, I would need 43.75 grams of lead. Okay, so that is just how we would do a question like this. I hope that makes sense. If it doesn't, then I need you to slow it down. Just remember, I got this here. It's probably going to be the part where you get confused. I got that by going 70 divided by 8. And that's how I got this number here. All right, and so I just do the opposite to come back around. Okay, see how you go with that. Now, I'm going to try the next question. There's a different type of question where it's very similar, but now we've got 3 parts here. So if we've got 3 parts, I like using this blue. I don't know why, it looks nicer. Tell me if you think that looks nicer. So a piece of ribbon, all right, who cares about ribbon, is cut into 3 lengths in the ratio of 3 to 5 to 7. All right, the shortest piece is 12. Find the length of the longest piece of ribbon. Okay, so we've got 3 to 5 to 12. Now, if we've cut it in these lengths, guess which one's going to be the shortest length? That's the shortest, right? That 3 there has to be the shortest. 3 is shorter than 5, which is shorter than 7. There's no way to go around it. 3 is the shortest. Now, what did they say 3 was? The shortest piece is how many centimeters? It says in the question here, it's 12 centimeters. So how did we get from 3 to 12? Well, we times everything through here by 4. So it's going to be 12 centimeters to, what's 5 times 4? 20 centimeters to, what's the last one? 4 times 12 is 48 centimeters. So that means those are the 3 lengths that we've cut our, our piece of ribbon into. So if we look at this question here, how do we then answer question A? It says find the length of the longest piece of ribbon. We can see here the longest piece here is 48. So 48 centimeters is the longest piece. Okay, now the next question here is one that some people may rush to do and actually accidentally make a mistake, but it says find the length of the original piece of ribbon. So the original piece of ribbon means it was before it was cut. So that means before we cut it up into 3 different pieces of 3 different sizes, it was 1 piece. Now, how would I find the length of that 1 piece? Well, kind of already found it, haven't I? So there's a 12 centimeter piece, a 20 centimeter piece, and a 48 centimeter piece. All I would need to do is to add all those numbers together, and that would give me my total length, or my original length. So the length of my original piece. So it's just going to be 12 plus 20 plus 48. And as a total, that's going to give me 80 centimeters. I think that's right. Let me just double check. 12 plus 48 is 60, plus 20 is 80. Good. And so that's how you would answer these questions. Hopefully that helps. That's it for today, but I'll see you guys next time. Right, bye.